Spacesuits are one of the essential things every astronaut needs. It protects the fragile body of a human from the harsh and unforgiving climate in space. And with the development of new spacesuits, one company may be revolutionizing the need for spacesuits. Let's find out what they're doing today at Finance Per. But for more videos about finance, technology, and business, don't forget to hit that like button and subscribe. But before we talk about SpaceX's new spacesuits, let's have a quick view of its history. In the early 1960s, NASA introduced the term extravehicular activity, or EVA, for the Apollo program, where astronauts would leave their spacecraft to collect lunar samples and conduct experiments on the moon. This concept led to the development of the Gemini program, which focused on allowing astronauts to work outside Earth-orbiting spacecraft. Now, the Soviet Union, in a competitive race with the United States in crewed spaceflight, converted its single-pilot Vostok capsule into 2- or 3-person Voskhod spacecraft to compete with Gemini and Apollo. The Soviets then launched 2 Voskhod missions before the US launched its first crewed Gemini mission. But what's revolutionizing the Voskhod spacecraft was that it was equipped with an airlock, which allowed cosmonauts or Soviet astronauts to spacewalk. And when the Soviets did it, the first EVA was carried out on March 18, 1965 by Soviet cosmonaut Alexei Leonov during the Voskhod 2 mission. He spent 12 minutes and 9 seconds outside the spacecraft, wearing a spacesuit with a white metal backpack containing 45 minutes' worth of breathing and pressurization oxygen. During the EVA, Leonov had to rely on a tether or a connection with a spacecraft to control his movements in space. However, his spacesuit experienced issues due to the vacuum of space. The suit ballooned from internal pressure, making it difficult for him to operate his chest-mounted camera. When it was time to re-enter the spacecraft through an inflatable cloth airlock, Leonov encountered a serious problem. He entered the airlock head first and got stuck sideways, unable to get back in without reducing the suit's pressure, which could have caused decompression sickness. This added another 12 minutes to his time in space, and he overheated due to the exertion. The US was not gonna accept defeat. A few months later, on June 3, 1965, the US did their first spacewalk during the Gemini 4 mission, when astronaut Ed White spent 21 minutes outside the spacecraft. White was tethered to the spacecraft, supplied with oxygen through a 25-foot umbilical, and used a handheld maneuvering unit for motion control. Unlike the claim made by Soviet cosmonaut Leonov, White found it challenging to move around using the tether. But like the Soviets, the EVA faced difficulties due to a defect in the capsule's hatch latching mechanism, delaying its start and endangering the crew's return to Earth. The Americans learned from these mistakes, and it was not until Gemini 12 on November 13, 1966, that future moon astronaut Buzz Aldrin successfully worked in space without tiring. Aldrin spent 2 hours and 6 minutes outside the spacecraft, in addition to 2 stand-up EVAs at the spacecraft hatch for 3 hours and 24 minutes. But the success was more contributed to Aldrin's interest in scuba diving. This inspired the use of underwater EVA training to stimulate weightlessness, a technique still used by astronauts to practice conserving muscle energy. Today, NASA is currently using the Extravehicular Mobility Unit, or EMU. It is a versatile spacesuit designed to provide astronauts with environmental protection, mobility, life support, and communications during extravehicular activities in Earth orbit. This 2-piece semi-rigid suit has been in use since 1981 and was utilized by NASA's Space Shuttle astronauts until the shuttle program's conclusion in 2011. Currently, it remains one of 2 types of EVA spacesuits used by crew members on the International Space Station, or ISS, with the Russian Orlan spacesuit being the other option. But in 2019, NASA unveiled its plans to utilize the Exploration Extravehicular Mobility Unit or XEMU system as part of the Artemis program. This advanced spacesuit technology is derived from the knowledge and experience gained through the development and use of spacesuits in previous space missions. The XEMU system represents the next generation of spacesuits, designed to enhance the capabilities of astronauts during extravehicular activities in space. Fast forward to June 1, 2022, NASA took a significant step towards the creation of its spacesuits and its space exploration goals. They announced a partnership with Axiom Space and Collins Aerospace to develop and provide astronauts with cutting-edge spacesuit and spacewalk systems. These next-generation spacesuits will serve a crucial role in various missions, including those outside the International Space Station, lunar surface exploration as part of the Artemis missions, and preparations for future human missions to Mars. But Elon Musk and SpaceX think that NASA is working too slowly. SpaceX's work on their extravehicular activity spacesuit was a well-kept secret, and when it was finally unveiled, it showcased a remarkable leap in spacesuit design and technology. What sets SpaceX's spacesuit apart is its tailor-made approach for each astronaut, which significantly enhances mobility and comfort during spacewalks. The spacesuit is meticulously designed to fit the unique shape and size of every astronaut, eliminating the discomfort and limitations often associated with one-size-fits-all spacesuits. One of the key challenges in spacesuit design is addressing mobility issues, especially when the suit is pressurized. SpaceX tackled this challenge head-on by incorporating crisscross tensioners into the suit's joints. These tensioners enable astronauts to bend their limbs with greater ease while maintaining safety and mobility. Additionally, the suit's pressure levels were optimized to strike the right balance between safety and mobility, ensuring that astronauts can move freely and perform tasks efficiently during spacewalks. Automation also played a significant role in revolutionizing SpaceX's spacesuit. By eliminating bulky external valves, the suit became lighter and more streamlined, making it easier to put on and reducing the time needed for astronauts to suit up. Integration was another key innovation, as the spacesuit seamlessly incorporates the helmet, gloves, and headset, simplifying the astronaut's preparation process. Aside from that, the management of pressure and temperature is crucial in the harsh environment of space, and SpaceX's spacesuit accomplishes this through a single port connected to the spacecraft. Sensors embedded in the suit continuously provide vital information to ensure the astronaut's safety and comfort. Furthermore, the suit utilizes a custom air mixture with adjustable oxygen levels, eliminating the need for frequent manual adjustments and simplifying the exterior design. Now, we won't know if SpaceX spacesuits are truly revolutionizing, as it is still on testing. However, NASA has already proven itself, and with a new space race of companies competing to colonize Mars, we will see more and better spacesuits from rival companies and governments. But for more amazing videos about finance, technology, and business, don't forget to check out our channel. Also, don't forget to subscribe and click that notify bell for upcoming videos. For now, this is Finance Burr. Have a great day.